So my forces tutorial for Physics 11, some quick hints. Questions that I've told you that I like. There's a good chance you'll see those in the future. Probably on the written section, I'll start off fairly basic, like something like number 1. Number 1, I've told you the net force. Sorry, I've told you the mass. I've told you the net acceleration. It says, how large is the force? I think it just wants you to go F equals ma. No free body diagram for the very first written question. No winner minus loser. I'm just saying, hey, Kelly, do you know what force is? And it's mass times acceleration. Number 2, definitely there's going to be an elevator question. Number 3, definitely is going to be an Atwood machine question. Is there anybody who would like me to do any of those? And I will if you wish me to. Kelly, which one? An elevator question? So I'm going to start with this elevator question, but I'm going to change the numbers if that's okay with you. I'll clip it. And again, I can print up this tutorial for any of you that you want, or you can write this down. I'm going to make the person 750 newtons. Now it's a different question. And I'm going to have 1.8 meters. You know what? Let's exaggerate it. Let's have a good upwards acceleration. How about 4.7 meters per second squared up? And how about 3.2 meters per second squared down? Okay? There. Brand new question. For the elevator question, the key is I'm going to ask you to tell me what the scale measures, but that's not really what you're going to find. You're going to have to realize, what does a scale measure? Normal force. So even though I'm going to say, tell me what the scale reads, you're going to be saying, Duick really wants the normal force, which means this is a job for a free body diagram. Okay? A, what are the forces acting on this person in the elevator? Get the obvious one. Now, I can give you gravity in 2 ways. I can give you the mass, in which case you'll go, I didn't give you the mass in this question. In this question, I told you the person's weight. And weight is mg. I told you their weight in newtons. I told you this is 750 newtons. 800 in the original question. For what it's worth, if you know the weight, which is mg, if I know 750 is mg, how can I find the mass in kilograms? Well, it's either times or divide. You got to pick which one. Zach, convince me. Why? What's the g doing to the m mathematically right now in this original equation right here? What's happening between them? Multiply. What's the opposite of multiply? That's why you're doing grade 8 equation solving. Yeah, more complicated, but it's really still grade 8 equation solving. This person's mass is what? Can someone give it to me? And because I'm going to use this, give it to me to like 3 or 4 sig figs to a few decimal places. I doubt it'll work out evenly unless it's a big fluke. What is 750 divided by 9.8? 76.53. What's after the 3? Oh, that works then. 76.53. Okay, let's go back to my free body diagram. What else? What are the forces? Get the obvious one. You said gravity. What else? Is this person in free fall? So there must be another force. Which one? Now remember, Nick, the normal force is the force that a physical surface exerts up against you. So if you're hanging in midair or hanging from a rope, can there be a normal force? No, right? That was, I think you brought that up earlier. So why did I draw the normal force bigger? I hope I did it. Hope that looks a little bigger. Let's exaggerate my diagram. Connor, what'd you say? You're right. You know what? Technically, because it's accelerating up, but even if it's not accelerating and going up, if you guess, you'll still be okay. So far, so good. This gives me my equation. Now I'm going to use my tug-of-war equation. Who's winning? Darn right. By the way, unless you're getting 100%, nobody taking shortcuts here. I got a few kids that are trying to do this. I think it was you I was helping yesterday, and the first thing I said to you, or no, it was you. I said, I don't see a free body diagram. I have a tough time doing this with a free body diagram. And don't try and memorize an equation. What you're memorizing is, here's the approach, a good free body diagram, and you can use Newton's laws to figure out what size the forces have to be, and then winner minus loser is the only equation that you're going to use. It's a generic one that can be by the way, if you take Physics 11 or 12 with Physics 12 next year, I won't be teaching you a brand new equation in this unit. It's still going to be friction is mu times the normal force. I don't know the normal force. Oh, look. I know another force the same size as the normal force. And it's going to be winner minus loser equals your tug of war. I've snuck it all in this year. All we're going to do is get more complicated and on angles in Physics 12. But it's going to be the same approach. Don't try and memorize a new equation. It's going to be winner minus loser equals MA. Yep.
Like with the normal force though, if the elevator is suspended, would that mean there is no normal force?
Have you been in an elevator before?
Yeah.
Are you standing on a surface in the elevator?
Yeah.
We're drawing the free body diagram on you, on the person, not on the elevator. I agree with you totally. If I said, what's the free body diagram on the elevator, it would be gravity down, tension up, I think. But we're drawing it on the person in the elevator who, as far as they know, as long as the room is closed, doesn't really know that they're hanging in a minute, right? The only way you can tell is if you feel the acceleration in your stomach. Kelly, how would I get the normal force by itself? Convince me with authority. You're right. Say it with authority now. Add. Why? What are you trying to move over? That thing. Right? And so, Dylan, I will plus that to that side. That gets the normal force by itself. And I'll end up with the normal force equaling MA plus mg. Double check. Do I know mg? Hey, yeah, this is the complete 750. They told me the weight in the question. I can't remember if on your test I give you the guy's mass in kilograms or the person's weight in newtons. I almost think I do both in two different questions, so make sure you can handle either or. And do I know the acceleration? Yeah, 4.7. Do I know the mass? That's why I had to divide by 9.8 if they gave me the weight, 76.53. I have no idea what the answer is, but it'll be 76.53 times 4.7 plus 750, whatever the heck that is. That's for going up. Going down! Okay. Yo.
The way I did it is can you also like for the mg, can you put the weight and then calculate like the 76.53 and then times 9.8?
Yeah, you know what you'll get? 750.
Will I get the same answer as you?
Yeah, but I was lazier. I said, there's absolutely nothing wrong with saying, oh, that goes there times 9.8. But I'm telling you, that times 9.8 is going to be exactly 750. You know how I know? Because that's how I found that 76.3 in the first place. I think you're just doing extra work that you don't need to.
I did mine a different way too. I don't know why. Like on the original question,
Yep.
800, I said 800 divided by 9.8
Yep.
times 2, and it was 163
Stop. Times 2.
for the 2.5.
Oh, okay.
And then it was 163, and the answer is 963, so 800 plus 163 was 900.
So here's why.
But I don't.
In the original question, you went that plus that, because if you go 800 divided by 9.8, that's the mass, times the acceleration in the original question, and you added then mg, which was 800 in the original question. I just don't think you knew why you were doing it. I think you had to look at the answer and say, I'm 800 light.
Oh, there we go.
Okay, hopefully I've convinced you why we're doing it that way.
I get it's been much easier. The way you
Been that way since I taught the lesson. Let's go down, shall we, Zach?
yeah.
I'll pick on you since I've humiliated Kelly enough. Zach, going down, what are the forces act? Get the obvious one. Is this person in free fall? Oop. So there must be a force up. And Nick, since we're drawing the free body diagram on the person in the elevator, they are standing on a surface. Yes?
Normal force is zero.
Yep. So my equation is going to be mg, which is 750. Yes, you could go 75.63 times 9. I'm telling you, it's 750 because I gave it to you that way. Minus the normal force equals winner minus loser equals the net force, and Madison net. I've been so good. I was about 5 steps ahead. McKenna, I'm sorry. Forgive me. It's her birthday today too. Maybe there's some psychic thing here. I don't know. This one here, kids have a bit of trouble getting the normal force by itself. You could minus mg from both sides. The only problem is if you did that, you have a negative Fn. So my preference is to kill two birds with one stone. If you haven't had me, if you haven't paid attention, I don't like negatives. If I'm going to make a dumb mistake, it's going to be with a negative. I've learned over the years. So, Nick, what was your suggestion?
Just plus to that side.
I'm going to plus that to that side, making it positive, but there's still an MA on that side. I'm going to minus the MA over to this side. Can I do that in one step? We're okay? If I do that, I'll get gravity minus MA. Don't memorize that equation. Yes, I guess that's always the equation if you're accelerating down. I think that's a waste of brain space. If you can get there in 1 second with a good free body diagram and you know winner minus loser, I think that's a better way to get it. Oh, and also, then I can throw curveballs at you and you'll probably be okay. Right? It's the kids that try and memorize their way through Physics 11. I think I told you the story. I had a girl who I never taught in Physics 11. I had her in Physics 12, and she was the queen of memorization, straight A student. And by about November, I had her in tears because all I'll do is I'll come up with a different situation that's very easy to solve with a good free body diagram. Oh, but would require you to memorize yet an entirely new equation and keep that one straight. Don't. There's a reason I gave you guys a formula sheet. C. Is that okay so far, Zach? And you could take it the rest of the way yourself. I have no idea.
Where do I put the negatives, like, because it's going downward? Right?
No negatives.
No,
We took
they're not
we,
going
no. We took care of all that with our winner minus loser. In this unit, we never put in a negative 9.8 into the force equation. We took care of all that with our winner minus loser approach. Yep. C. What are the forces acting? Get the obvious one. Normal force up. Now, we're going to find out, as it turns out, that the normal force is 0. But if you weren't sure, I think you would still say, well, it's accelerating down, gravity's winning, I'll draw normal force shorter. I think you would say gravity minus normal force equals ma, just like we did in B. I hope, Connor, you would get the normal force by itself, and you would say mg minus ma equals the normal force, just like we did in part B. And then you would say mg is 750 minus, what was the mass? 76.53. What's the acceleration? And again, Zach, we don't need to put the negative. By the way, where we're including the negative is when I go winner minus loser. That's taking care of any negatives that we need. And if you try typing that on your calculator, what is 750 minus 76.53 times 9.8? It's 0. And what you're really showing is that if you're in an elevator and the cable snaps, do you know how much you'll feel like you weigh? Nothing. You'll be floating. There's certain amusement park rides that can simulate that temporarily. The Superman ride at Six Flags, for example, at the very, very top, if you take a penny in your, because you're locked in the shoulder straps, if you hold a penny in your hand, at the very, very top, if you open your hand for a split second, the penny will float there because you and it are temporarily weightless. And then on your way down, it'll accelerate. Or if you're wearing a necklace or a chain, it'll appear to be floating out. It's not, it's temporarily weightless. It's the elevator cable has snapped. What if I said you were moving up at a constant speed? So what if I added a part D, I'm just making this up, but it's good teaching, and I said up at a constant speed of 8.2 meters per second. Okay, you made a great connection. You would say, yes, let's prove it. He said, I think the normal force and gravity would be tied. Yeah. What if you weren't sure? You would say, well, what are the forces acting? Get the obvious one, Zach. You'd probably say, well, it says up, so if I'm not sure, I'll assume normal forces win. I don't know. My equation then is going to be, Joel, winner minus loser equals. But if you're at a constant speed, what's your acceleration? It's mass times 0, but what's anything times 0? 0. And, oh, look at that. Connor was right. He said, Mr. Dewick, wouldn't the normal force be just the same as gravity? We just proved it.
Oh, good, yeah, if you just move it over and
What this is saying is you can't tell in your body if you're moving at a constant speed. You have no way of telling it. If you're in a smooth elevator, once it stops accelerating, you get nothing.
so with these elevator questions, like, it says constant velocity, which is 0.
What's 0? You said it.
Well, no, I
That's
mean,
too
I
big a
mean,
question.
normal force equals gravity.
Yeah, so this is how I would answer you. If we're at a constant speed or velocity, you know your acceleration is 0. If your acceleration is 0, your net force has to be 0,
Okay.
which means your forces have to be balanced. And you know another fancy phrase for balanced is equal. Okay? I have to be careful how I answered you, though, because as soon as you said it is 0, I was like, well, there's a lot of it's out there. Okay? That's number 2 in all its various permutations, I think. You're either going to be accelerating up or accelerating down, or, oh heck, free fall is a fun one because, oh, it's free fall, or traveling at a constant speed up or down, or, you know what? I don't think I can come up with another permutation. I think that's all of them.
Number 3.
Yep, the Hatwood machine.
Yeah.
Sure thing. Clip. So I'm going to give you an acceleration, and I'm going to say, sorry, I'm going to give you an acceleration. I'm going to give you an Atwood machine. I'm going to say find the acceleration and find the tension. Oh, let's do this, Zach. Let's just, to change the masses, put a 1 in front of each one. Just, you know what, let's put a 1 in front of the 4. So we got a 14 and a 12. Good enough. Now it's a totally different question. In fact, I think now I got a different winner. The diagram looks kind of funny because the heavier mass is smaller. It's gold or lead or something really, really dense. Good enough. Okay. First thing I would do is I would label my forces. Now, labeling my forces would just be saying, well, it's gravity down. What did I call that force there? Yeah, and how do I know it has to be there? Because it's not in free fall, so there must be something slowing it down. I would call this M2G. As soon as there's more than one mass, Kelly, I start numbering my masses. It's an easy way to stay organized. Don't be sloppy. And tension. Now, if I said, hint, draw the free body diagram for this. If I said, for mass 1, who's winning? That mass 1 is not a force. I got to be fussy.
Gravity.
Okay, M1G is winning, or I'll call that gravity. I'll accept that. But if you just say mass 1, mass is mass in kilograms. So which force is winning of the 2 that I labeled on my free body diagram? Well, mass 1 is the heaviest mass because I added the 1 in front of it. It's going to be falling down. Who's losing? Tension. So I would look for, in your free body diagram, Nick, for tension clearly to be shorter. I'd probably even exaggerate it even more than I have. Not when I added a 1 in front of it. I made this 14 kilograms now, and that's 12.
Oh, it's
Right?
Could M2G be losing as well, or no?
Pardon me?
Like,
Oh, if I said draw a free body diagram for mass 2, that's a great idea. What are the forces acting on it? M2G. Which way is M2 accelerating, up or down? Up. So that must mean the winning force is that way, and that's tension. See the difference? Whoa, sorry, I don't know what happened there. Now, if you really wanted to be fussy, and I won't be, but if I was really, really being fussy, because, Kelly, this tension and this tension are the same, technically they should have the same length, and then this should be shorter, and this should be way longer. Whatever. But I'm pretty sure somewhere on your test, I'm going from memory, I think I give you an Atwood machine, and as part of it I said, draw a free body diagram for one of the masses. What I'm really saying is, you better clearly show me which one's winner. Which one's shorter, which one's bigger. But to solve this, the trick that we do is we treat this as one mass. To find the acceleration, who's winning? M1g. That means that anything that ends up pointing down on the left-hand side is going to be winner plus. Anything that ends up pointing up on the left-hand side is going to be loser minus. Winner. Loser. And you might be tempted to think this tension is a loser too, but Zach, follow it, follow it, follow it, follow it. When it gets to this side, I think this tension is pointing down in what we've decided to call winner. And by the way, this is why we don't need to include the negatives. We decided to let down be positive for convenience, because the math is much nicer. So there's going to be a plus tension. And again, Zach, you might be tempted to think that this gravity, because it's pointing down, is a winner, but follow it all the way around to the other side, and when it gets to the other side, which way is it actually pointing? Loser. The force, not you. Well, maybe a little, okay. Column A, column B. How many masses do I have on the left-hand side? Can you see in the equation? 2. You know how many I better have on the right-hand side? Can you read to me, Matt, the bracket there, please? Nice and loud.
M1 plus M2
What did you say? M1 what?
plus M2.
Every year, for some reason, I have a couple of kids that write M1 plus M2, and then they multiply them together for some reason. Instead of this working out to 14 plus 12, 26, they tell me, they put the number 14 times 12, whatever, 100 and whatever. No. Plus means add. Both, mass of both means add. So don't do that one. Why am I nodding off? I'm losing tension. Could do that by making Zach show up on time. Oh, sorry. When you show up on time, you reduce a force in my free body diagram. Right?
Not often.
Not often we can say that, but it'd be true here. I think the first thing I said was find the acceleration, so I need to get the A by itself. How? By? You're right, but by what? Okay. So final answer, divide this whole thing, and you end up with the acceleration being m1g minus m2g, all divided by m1 plus m2. Joel, don't memorize this equation. You can derive it in 3 or 4 seconds, right? Oh, and it's a different equation if the other mass is winning. Oh, and it's a different equation if we add a different mass, so there's 3 of them. Oh, and it's a different equation if it's a different equation. Don't memorize all the different permutations of this. I'm giving you a method that if you relax, good free body diagram. The rule of thumb is, Kelly, if you have more than one mass, but you know every mass, winner minus loser equals the mass of both times A, all the forces. Are you okay typing that in yourselves? It would be 14 times 9.8 minus 12 times 9.8 divided by 26, whatever. I don't really care what the answer is. I'm just making sure you can get the method, okay? How would I, you know what? We are going to need this answer after all, because to find tension, I need this answer here. So it's going to be, what did I say, 14 times 9.8 minus 12 times 9.8 divided by 14 plus 12, which I'm pretty sure is 26. Bracket 14 times 9.8 minus 12 times 9.8, close bracket, divided by 26. Again, acceleration of 0.7538. I'll call it 0.754. Acceleration is meters per second squared. Is that a very big acceleration? No. Are the 2 masses almost identical? Oh, in fact, it's almost able to stay. Right? If it was 12 and 12, it would happily stay at whatever alignment we put it in. Just like with my little toy here. Right, the 2 masses are the same, so it'll stay like that just fine. Or it'll stay like that just fine. Or it'll stay like that just fine. The masses are the same, what do we care? But, so since the masses are nearly the same, I'm expecting a pretty small acceleration. What's the threshold? What's the biggest the acceleration could possibly be?
One.
What can't we possibly accelerate faster than if we're talking about dropping an object?
Gravity.
Yeah, can't get an answer bigger than 9.8. If you get an answer bigger than 9.8, you've made a calculator mistake. It's a nice built-in error check. Because gravity would be if we cut the rope and it wasn't having to tug on any kind of a mass and lift it up, right? We haven't got that. So there's a built-in error range. Bigger than 0, smaller than 9.8.
Keep getting 140.
So you're typing it in wrong on your calculator.
I keep on getting 132.6.
Speaking of Zach, let's find the tension. See? How do I find tension? I pick, yes, I have to go focus on one mass. Which one? Doesn't matter, you'll get the same answer for both, although often one will be easier. I try and take the one in which tension is the winner because it gives me an easier equation with less negatives, and I already went on my rant about how much I dislike negative numbers. So, in which one of these is tension the winner, mass 1 or mass 2? Because that's the one that's accelerating up. So now we're going to target mass 2. Winner minus loser equals mass 2 times A. Glad you made it, sir. Better late than never, but better never late. It's going to be tension minus M2G equals M2A. Mr. Dewick, why didn't you include mass 1? We're not looking at both now. Now we're just going to look at one mass and analyze it. If you want to do mass 1, go ahead. There it would be M1G minus tension equals M1A. The reason I like this one better is it's easier to get the T by itself. Barely easier, so really this, it's kind of 1 and 1A. They're almost the same. I think the tension is going to be M2A plus M2G, which is 12 times 0.74 plus 12 times 9.8. We're going over the reviews, but I'm just changing the numbers on some of them.
Okay.
It's going to be 12 times, I think I still have that answer stored, so I'll use that, plus 12 times 9.8. This would have a tension of 1,063 you know what, I'd probably call it 1,060 to 3 sig figs is pretty accurate, or 1.06 times 10 to the third. Units, what do I measure tension in? What is tension? It's a force. What do I measure force in? It's what I measure tension in.
If you do the other one, like,
Yep. So if you did the other one,
you would just add tension on one side and minus the one
yep,
side.
it would be M1G minus tension equals M1A. You would do my trick of yoink, yoink. You'll get tension equals M1G minus M1A. M1 was 12. No, 14 times 9.8 minus 14 times 0.754. And why am I way off here? Was I wrong on the 1,000? I was wrong on.
That, what you just thought. I can't find how you got your other number.
I think I had another number stored in there. 12 times 0.754 plus 12 times 9.8. You know what? It's not 1,000 something. That seemed way too big to me anyways. I should have caught that. I did a calculator error, Joel. See, I do it too. It's 127. 126.6 something, 127 newtons. And I got the same thing here. 127 newtons. Okay. I like number 12. Let's look at number 12, please.
Can you remember numbers as well, too?
Yep. Number 12, little rocket science. What was number 9? Yes, but I think we're going to do one very similar to it in the next couple of questions anyways, so let's see. 12. So what we're doing, Jordan, is just changing the numbers to make a whole new question. You ready? Something like this. A rocket which weighs, hey, let's do our trick of, let's put a 1 in front of it. 19,650 newtons. A big rocket is launched. The force of propulsion is 65,000 newtons. I'm just making numbers up. This could be going way too fast, but I'm just making them up. Okay? So let's make this a bit more obvious. 19,650 newtons. Now, please notice I gave you the weight. When I say weight, what is that really? That's mg. Weight is this, it's interchange. When I say the force of gravity, we call that the weight. When I say what do you weigh, it's really mg acting on you. So how can I find the mass if I know the weight for part A? Nick, you're right. Loudly. The mass is going to be 19,650 divided by 9.8. So not this answer. I have no idea what the answer is. 19,650 divided by 9.8. 2005.1. Because you know that 0.1 is really important. 2005, really. Kilograms. B. Kenna, what are they asking me to find in B? Have they mentioned the force of propulsion in the question? Yeah. Have they mentioned weight, which is the force of gravity, in the question? Is there more than one force then? This is a job for a free body diagram. We're going to do our rocket ship just after it's left the ground. So let's say 10 meters up. What are the forces acting on it? Get the obvious one. Which I told you was 19,650.
How do you know when to use the free body diagram?
Did they give me more than one force?
Yeah.
Then you better go winner minus loser. Also, if you want a dumb test way, I think the first couple of questions on the written section are just plug and chug, no free body diagram, and then suddenly when it gets tougher, or if you really want to, probably if it's worth 2 or 3 marks, it's going to require a free body diagram. If it's worth 1 mark, it's probably straight plug and chug. That's not physics, but
So 65,000 newtons is Fm.
it's not Fn. Why can't it be a normal force? It's not on a surface.
Oh, so F.
Let's call it, sure. You know what, to be honest, if you want it, in rocket science, it's thrust, but let's call it FP. Winner. I don't know, what does FP stand for?
Approximately.
Force of propulsion?
Fm.
Yes. It's really not a grade 12 word, mister. I think it's, okay, leave him alone.
I didn't even read it off there and put it off my
Yeah, my English is more gooder.
Yeah.
Jack, who's winning?
MG, whatever.
Really? That would mean that this rocket was sinking into the earth and couldn't possibly get off the ground.
Oh, yeah, okay, no. Yeah, the other thing.
Which force is that?
Force of propulsion?
Propulsion.
Propulsion. Having troubles here.
I know. That's why I'm enjoying this.
Propulsion.
So that's winner, and if there was any other upwards forces, I would call them plus winner. There aren't. 1 loser, and 1 mass, so it's going to be equal to MA. What are they asking me to find in part B? We found A, the mass. Sorry, what are they asking me to find in part B? Oh, I guess I got to get the A by itself. How? More specific. By the way, if you haven't figured it out, when you just say divide or add, I'm always going to say, by what? So, divide by the mass. I think the acceleration is going to be the propulsion force minus mg divided by the mass. It's going to be 65,000 minus mg. Now, I could go mass times 9.8, but if I'm really, really clever, Connor, I can't help noticing that they did that for me already when they did that 19,650. That is mg already, so I'm just going to do that. Divided by the mass, which was 2005.1. So I'm going to go bracket 65,000 minus 19,650 close bracket divided by previous answer, since I still have that stored. Ah, that's not too bad. What's 1g as an acceleration? Well, usually when we talk about g forces, we don't include the negative. Yeah, 9.8. What would 2 g's be? Double it. You know what? Let's use an even rounder number. What's 9.8 close to as a nice number to do math with? So 2 g's is about 20. That's a little more than 2 g's. The astronauts pull about 2.5 to 3. So actually, I fluked into making some good numbers here. I'm sorry, but I'm always happy when my rough mental calculations is like, not violating the universe law. You get an acceleration of, what did I say, 22.6? What's C asking us to find? Mr. Duck, you mean is the stuff from last unit fair game too? All year. Yeah. So you said the velocity of the rocket at the end. In terms of our terminology in our formula sheet, let's defic. What are they asking me to find? Which V? Which velocity? Final. That must mean they told me V initial, I bet you. Did they? Oh, did it say it's from rest? Good. And I just figured out the acceleration is 22.6. I bet you that's why part C came after part B. That would make sense. And what else did they give me in part C?
The mass. Wait.
How can you be obviously confident that it's time? Units? Oh, I actually have an equation that already has VF by itself and has a VI and an A and a T in it, right? And go to town there, whatever the heck it is. Fairly fast, I would imagine. Okay. So there's 12. Connor, you asked me a question a few minutes ago. Do you remember you said, hey, Mr. Dewick, how do I know when to use a free body diagram? Remember that? If you look at 13, 14, and 15, there is a word that begins with the letter N. It's 3 letters long. Can you spot it? The other way you know that you don't need to worry about a free body diagram is if I give you the net acceleration or the net force or the net whatever. Because really what I've done then is I'm giving you the right-hand side of the equation. What I'm saying is I already did the winner minus loser thing. Don't need to. Okay, so there's another way. Pardon me? Sure. What are they asking you to find?
That acceleration.
Acceleration. What did they give you? What's that 9? What's that 180? All they want you to do is go acceleration equals force divided by mass. Because F equals ma. It's going to be 180 divided by 9. So why can I do that so casually? Because they gave me the net acceleration. They've already combined all the forces. I don't need to worry about trying to do blah, 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 blah. Apparently, when they added all the forces up, when they did their free body diagram, when they did all the math, we ended up with an a net force of 180. It's got a mass of 9. That means it's accelerating at whatever 180 divided by 9 is. Is that okay, Nick?
So it's equal to F divided by M?
Yeah, because it's F equals ma, get the A by itself, right? Number 13, it's F equals ma. They want the net force, so you already got the F by itself. Number 15, it's F equals ma, get the M by itself. How do I know it's going to be, I think, F divided by A, right? How do I know that? Because all 3 of those are giving you the net whatever, which means they've done the free winner minus loser free body. Okay. 16. Flip. You're not that important. An object with a mass of, how about 36 kilograms has a weight of, how about, 960 newtons. Okay, same question, different numbers. What's the acceleration due to gravity on this planet? You know what they're really asking me to find? That. That's the symbol that we've used for the acceleration due to gravity. We have two ways to find it. The one way is trickier, using gravitational field strength. If I want you to use that, I'll either give it to you in the question or I'll put it on your formula sheet. Have I given you the mass of the planet in this question anywhere? Have I given you the radius of this planet in this question anywhere? Then don't do that. Sorry, say that? Or with my new numbers, please? You're right.
Oh, 960 divided by 36.
If gravity equals mg, then g is probably gravity divided by m. 960 divided by 36. Apparently on this planet,
I just used the F equals MA.
yeah, that's what,
Why just catch up to G with big G?
ready?
Yeah.
If we're talking about the force of gravity, didn't we call the acceleration due to gravity? Didn't we symbolize that with a g? That's where that mg always came from. It is a force equals ma. Okay? So I said, oh yeah, you want to get the g by itself? Divide by m. And I put the subscripted g there to remind myself that's the force of gravity. That's the weight. That's the 960 divided by the mass. You were totally right, kiddo. I have no idea what this is. I'll be stunned if it works out evenly. 26.66666666. What's B asking me to find, Dylan?
Gravitational field strength.
You know what gravitational field strength is? It's that, which I think I just figured out in part A. Yep, 26.7 meters per second squared. Although it's traditional when we're talking about gravitational field strength to call it newtons per kilogram, to emphasize that we're comparing a gravitational force on a mass, but that is still meters per second squared.
So acceleration due to gravity is like how fast it is pulling up and down. Right?
Yep. So on this mystery planet, when you drop something, instead of falling at negative 9.8, it would fall at negative 26.7. Oh, and by the way, when you drop something and you measure its acceleration, that's the gravitational field strength, which is on the Earth 9.8, here 26.7. For this question, with the original numbers, apparently 24 and 24. Oh, C says, what would the weight be? Well, how would you find the weight if this was on Earth? Not 120, because kilograms isn't weight. Weight is gravitational. You would just go this times 9.8 to get the weight if you were on the Earth. Right? Guys, got to get this. Weight is another word for that. They're interchangeable. If I say, what's the weight? What I'm really saying is, what's the gravitational force? What's mg? So, if you know the kilograms, times by 9.8 on the Earth. Oh, are we on the Earth in this question? What's the equivalent of the 9.8 in this question? 26.7. Or in the original one, times by 24 to get that answer. So you'd go 125 times, I still got that on my calculator, times that number by 125, and it's going to have a weight of 3,333 newtons. Okay. Is that all right? A couple more, we're good. And then I'll take individual questions. 17 was an elevator question. Have we flogged that together already? We did that before you got here, kiddo. Okay.
Can we do like one of the box sliding?
Like number 18? Okay.
As you do it,
Yo,
are you gonna be here tomorrow morning?
it's hit and
Block
miss with
F.
traffic, and my
Block
block F is, so it's hit and miss tomorrow morning with traffic, and my block F is my prep. So if I'm going to be late on any day of the week, it may be the Thursday, because if I have to suddenly pick something up on the way, it'll be that. So you're welcome to try. I will be in my room tomorrow at lunch. What block are you?
E.
Oh, that won't help. Sorry.
Yeah.
Or I'm going to put this video online. You may have to watch it later tonight and catch what you missed. I'll email out this video. So let's do this one, which is what you were wondering about.
Yeah. It's the same, it's like kind of the same thing as number 9 and 10.
This one is the more universal, and then we can adapt 9 and 10 to fit this one pretty easily. Okay? Let's do our usual changing of numbers. How about applied force is 940? How about the coefficient of friction is 0.35? And let's make the mass 14 kilograms. A says, draw a free body diagram. All right. What are the forces acting on this mass? Get the obvious ones. Really? Gravity down. Is this box sinking into the ground like quicksand? Is it lifting into the air like Superman? See, that's Newton's first law. That tells us that the forces must be balanced, because if they weren't, it would have to be accelerating up or down. Since it's not, forces must be balanced. Nick, what do I call that force from a surface? Darn right, because it's normally there. What else? Well, looking at the diagram, there's an applied force. How do you know there's friction? There's a mu in the diagram, and it talks about the coefficient of friction. And friction would be that way. There's your free body diagram. And you'll notice, Joel, I haven't bothered memorizing an equation, because by writing the free body diagram, I think the equation is screaming out at me. Vertically, everything's in balance, so who cares? But horizontally, who's winning? Darn right. It's obvious, yes? You can see it. I think you were the one that was trying to memorize everything, if I recall, so I'm breaking you of that habit. I agree with you, Joel. It's this. Who's losing? Okay. Now, let's go back to Connor's question. Connor said, what about number 9? I think in number 9, you're prevented from moving. Is that what it said? Can you look at number 9? I'll go look myself. Oh, it just starts to move. What that really means is it hasn't started accelerating yet. It really is saying this. Sorry, the people on the internet can't see that. It's really saying that this is 0, which means what?
Force applied, same as friction.
Yeah. Take it from there. Okay? And I think also number 10, you're already moving, but if you're moving at a constant speed, which I think is what number 10 says, what's your acceleration? So friction and applied have to be the same.
So 9 and 10 applied equals that friction.
Pretty sure, but I haven't memorized that equation. I would do a free body diagram, and I can derive it every time. Hope you're picking up on my hint here. Here, though, B, what are they asking me to find?
Acceleration.
Okay, how to get the A by itself, and don't just say, he's learning. I thought I was, again, I'm going to divide by what? Divide by the mass. So, acceleration is going to be the applied force minus friction divided by the mass. Let's start to plug in numbers. Applied force, 940 in my made-up example, minus, now friction, they didn't give me the force, they gave me the coefficient of friction. Oh, this is really the second big equation in this unit. The two main equations in this unit are F equals ma, and friction equals mu times the normal force. Except I don't know the normal force. Oh, but look. I know another force the same size as the normal force. In my free body diagram, what is the same size as the normal force? Darn right.
Okay, so wait, why do you, is that just like, is times the normal force on the line?
Friction is, our equation for friction is defined as mu times the normal force, where mu is the coefficient of friction. It's a unitless measurement. It's how sticky an object is. Closer to 1, closer to glue. Usually it's a decimal, right? I think ice is about 0.1, slippery. Road tires are about 0.5. On a hot summer day, about 0.7. On a rainy day, about 0.3. So 0.5 is about an average-ish. Okay.
The mass is 14.
Yeah, in my made-up example, so it would be bracket 940 minus 0.35 times 14 times 9.8. This could be a huge acceleration. Looking at, I'm trying to do this in my head. I think my force is way too big. This is like a small mass being yanked on by a semi-truck or something.
So it's 940 minus 0.35.
0.35 times what?
9.8.
You missed something. No, mu is 0.35. What's next to the 0.3? What's next to the mu?
Math.
14.
14.
Come on, Ben. Times 9.8 divided by 14. Of course, Joel, I'm going to put a bracket around the top. Yes? Right. Bracket. And then I'm going to go 940 minus 0.35 times 14 times 9.8. Close off the top divided by, do I have more than one number on the bottom? Then I don't need a bracket. Yeah, I get an acceleration of 63.7. Just,
Mr. Dave,
yo,
can you look at this question and take calculator there?
can I what?
Take calculator there. It says 12 kilograms, and then we're using,
I changed it to 14.
I know, but I mean, it says 14, but then we're using mg here, and that's what.
Well, no, what's m in this question that I made up? 14. What's g as long as you're on planet Earth? 9.8. Okay, so when you're doing this,
I thought it was a way to change from g to mg.
no, I gave you this in kilograms. I didn't give you the weight, I gave you the mass. So that's going to be a full mg. If I'd given this to you in newtons, then that would actually be whatever mg was.
So instead of newtons, that stands for energy.
No, newtons is a force. Okay, you guys are trying to memorize. I'm saying generalize. Newtons is a force. So if it gives it to you in newtons, they've given you a force. But if they call that weight, what force determines your weight? Gravity, mg. That's how you know if it's a force, it has to be mg. Oh, if I want to get the m by itself, I guess I better divide by 9.8. Okay? Let me write this down first of all. 63.7. That's crazy. How many g's is that? Divided by 9.8. I'm just curious. Yeah, that's 6.5 g's. That would jerk you something pretty heavy. I think the human body can survive about 10 g's injury-free, so that would already bruise you pretty heavily if you were a person instead of a box being yanked on by this semi-truck or whatever. So far, so good? I hope. Did I answer your question okay, Connor?
Yep.
Yeah? Okay. That was 18. 19 is another Atwood machine, so that's one that you can practice. 20, this is an Atwood machine, except here it's going to be yoink. More than one mass, so technically an Atwood machine is when both masses are hanging down, so I can't call this an Atwood machine. More than one mass! Hey, what are the forces acting on the 5 kilogram mass? Get the obvious one. I'll call that M2 because it's the second mass. What else? Tension. What are the forces acting here? M1G. Normal force. Any friction? Says mu equals 0, so none, right? Tension. Now this question is a bit tricky. It's asking for the mass of the block. I'm not going to give you one that yucky, that tricky, but your equation would be who's winning?
Plus 2g.
And then you'd have a plus tension because that horizontal tension goes around. Now, a lot of kids want to include gravity. Look, I'm telling you, gravity is not acting along the rope. What we're doing is we're walking along the rope, and when I walk along the rope, I don't run into normal force or gravity. I only have, in this case, 3 forces. And that equals M1 plus M2 times A. That would be
Why
it.
don't we put minus m1g?
It's not in the same direction as the rope. Look, walk along the rope. When I get here, it's horizontal forces. Here it's vertical forces, but here the rope is horizontal. Is gravity horizontal? Then it's not slowing the rope down at all. They're balanced vertically there.
You know that once on the Atlas machine, we go like M2G minus 10
Yeah.
plus tension minus 10 on the machine.
Yep, because there, all of the forces ended up being in the same direction as the rope.
Why would we use the one tension? Shouldn't we get rid of one tension schemes right now?
We're walking along the rope. Ready?
Yeah.
Walk along the rope. You hit this force, yes?
Yeah.
Keep going. You hit this force, yes? Keep going. You have to turn a corner to your left to follow the pulley. You hit this force. Better include it in your equation, yes? Keep going, keep going, keep going. Nothing else.
So you don't put MLG in.
No. No, 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 no. I'm telling you. How could you? Now you're adding a vertical to a horizontal equation. Over here on this side, there's verticals, but that's because the rope has gone vertical here. But on this section right here, the rope is horizontal. Then in your equation, if you're writing the forces that are in the rope, please only include horizontal forces. If there was friction, you would have friction slowing us down. That's physics 12. Although next year I'm going to do that in physics 11 because I think it makes it clearer.
So I'm like pretty much normal force and gravity are like equally when included.
You're trying to memorize a specific situation. I can't answer that yes or no. It all depends on the diagram and it depends on the situation. What I'm saying is, if there's a rope,
Yeah.
start walking along the rope and include any forces that end up in the same direction as the chunk of rope in that section of your diagram. Because I can think of a way where normal force would be included. It would all just depend on how this was hanging. If I gave you this, don't write this down. Pulley, mass hanging in midair, M2. Mass 1 sitting on a surface, M1. Well, now it's sitting on a surface. Now normal force would come into play, tension would come into play, and gravity would come into play, because if I walk in the direction of the rope, they all end up in the same direction as the rope. However, if instead we do this, in this section, I'll do any forces that are in this direction, but in this section, I'll do any forces that are in this direction, because the rope has turned 90 degrees. And that's really our argument for many body problems. What we're saying is, look, if they're attached by the same rope, they have to accelerate at the same acceleration, because they're attached by a rope. So let's list all the forces acting on the rope. Is that okay for a rant? I hope. But 20, I'm not going to ask you to find the mass. That's a little tough. Same with 21, I'm asking you to find the mass. Don't freak out about that.
We're not good at it already.
If you can do them, they're great practice, but you have to do some thinking. What I wouldn't say is don't spend 20 minutes freaking out over this.
Alright.
Okay? 23, though, is fair game. I gave you both masses. 24, again, I'm not going to freak out if you can't get this one. It's nasty. See if you can get it. But if you want to find the test easy, if you get the hang of 24 and you find the answer is 0.333, you're in good shape. Tug of war is a nice question as well. A good free body diagram and see if you can figure it out. But that's, again, slightly tougher than I'm going to ask on the test. Then we come to the gravitation section. So that's kind of what's going to be on your test. Did that help, I hope? Yes.
Did you use a gravitation question or anything?
Can I do a gravitation question or two? Sure can. So what am I going to ask you?
You're gonna give us all the equations in the test, correct?
I'm giving you have a formula sheet that has the equations. What you really mean is I'm going to give you all the data that you
Yeah.
need. Yes. Yes. Okay. Let's do. Sure. Gravity questions. Calculate the force of gravity between 75 kilogram mass and 68 kilogram mass if they are 0.63 meters apart. Have you looked? Since I notice a yellow piece of paper right near, right from, oh, look at that. I photocopied it on a bright yellow piece of paper so you can find it easily.
Look at that.
Ah, wow. Who knew? Like I said, I don't make you guys memorize much. I'm not a fan of memorization. What are they asking you to find here?
What's the graphs?
Am I just going to go mg? No. You know how I know? More than one mass. Now they're talking about using Newton's universal law of gravitation. It's going to be where big G is 6.67 times 10 to the negative 11. Okay? Do you want me to crunch the numbers, or is that enough to get you going there? Is that good, or do you want me to crunch the numbers, or what?
You're already there.
I have no idea what your response is when you say you're already there. Does that mean quit because I'm already there, or does that mean keep going? Keep going. Okay. Little quicker feedback than that, folks. Even when I ask you an either or question and someone says yes, that really doesn't help me with my either or question answer. Not mentioning any names. Okay. Don't confuse big G with little g. Little g is the gravitational field or the gravitational acceleration on the Earth. It's 9.8. Big G is Newton's universal law of gravitation. That's the number that we have to multiply kilograms times kilograms divided by meters squared in order to get a Newton's as an answer. And it's 6.67 times 10 to the negative 11. Mass, 75. Mass, 68 divided by 0.63 squared. When you do it, you should get 8.57 times 10 to the negative 7 newtons. Pretty small.
That 6.67 number is big G.
Yeah, has been all unit long. Always.
How am I supposed to memorize that?
I don't know. Do you have a yellow formula sheet? Maybe you want to see if it's on there. It is on there, isn't it?
I don't see it.
About an hour. 8.57 times 10 to the negative 7. Units? Figure it out. Why newtons? You're right. Why? It's a force. Turn your brain off. It's a force. Okay. And then what I said, McKenna, is I have no problem giving you both of those and that, find FG, but I have no problem giving you this, that, one of those, find the other one. I'll make one up like that in just a second. Or I have no problem giving you both masses, find the distance between them. I'll make one up like that in just a second.
You do one like number 4.
One like number 4. I don't know. I just did. What's it asking you to find in number 4?
What's gravity?
So
Then there's all like the radius, Mars, and
that's the distance squared. It's the same question. It's just bigger numbers. Is that what you're scared on with?
no, just like the radius and the mass.
That
of the actual
okay?
line.
So you ready? Big G is 6.67 times 10 to the negative 11. Mass of Mars.
Oh, okay.
Mass of person standing on Mars. Distance from center of the planet, which we would call the radius. I'm telling you, it's the same question. It's bigger numbers, but it's the same question. It's the same skill. Okay?
Is there gonna be a question where, there's like a radius and then the person's farther and you have to like add it?
The altitude one? No, physics 12 there will be. No, not physics 11. I don't think. I'm pretty sure. How far apart are a 76 kilogram mass and a 65 kilogram mass if the gravitational force of attraction between them is 6.53 times 10 to the negative 7 question mark. Let's make that an exponent, Mr. Dewick. Yoink. So here's one. How far apart are a 76 kilogram mass and a 65 kilogram mass? The gravitational force of attraction between them is that big.
What's the exponent beside the 10 on 6.5?
Negative 7. Okay.
So for that one, can you multiply out D on the left? And then there's the
Nick.
I have a feeling it's square root of something.
Oh, Nick, you just made my day. Now I'm only grumpy with that corner, but now I like you again. So you're saying I would do that, and that would give me d squared, but if I heard you say, I'm pretty sure a square root's going to show up to get rid of it. Yeah, it's going to be that. And I'll, carefully do the numbers on my calculator, but it's going to be 6.67 times 10 to the negative 11 times 76 times 65 divided by that. Some of you need to practice your calculator, I can tell, so let's write this out.
Where is the square?
Hang on. Just a reminder, I will be printing this up for you, so if you're missing stuff because your head's down, there is a remedy for that. You could always just trust me to print this up for you afterwards.
No, I just don't know like the square. Why are we square rooting?
Look what did I circle? Can you look behind me? Okay, let's try this again. Look at the screen, kiddo.
I want to square root both sides. Like you're square rooting.
I got the d squared by itself is really what I did here. So it was this. How'd I get rid of a squared? Square root.
Okay, I just didn't see like
Yep.
the square root.
It's okay. Meanwhile, let's crunch the numbers. When you're square rooting something this ugly, don't. Type the inside first, get an answer, and then go square root answer button. Trust me. I'm going to go 6.67, scientific notation, negative 11, times 76 times 65 divided by 6.53, scientific notation button, negative 7. Square root of that. They're about 0.71 meters apart, about 71 centimeters. Oh, not far. Okay. The only other thing I can do is, just like I did here, give you the gravitational force. But instead of saying find the distance between them, give you the distance, give you one mass, find the other one. And what that would be, and Nick, you were on, it would be times by d squared, divide by big G, and divide by the mass that you know. And that would get the mass by itself. Cross multiplying. You had a question, did I answer it? What was your question? Can't remember now. I did answer it though? Okay, my brain was somehow telling me that I hadn't.
Could you do it the other way? Like say you can do like M2. Could you do times by M2 and it's minus MG and then
No.
no,
Why minus? There's not a single plus or minus sign in there. It's got all going to be dividing and cross multiplying. Okay? Any others? I think we're winding down. Sorry? Okay, so that I did a couple of gravitation. You know what? You all need to work through the study guide. In terms of questions, I'm not going to freak out that you can't get. I would certainly say 24, 21, 20. So 20, 21, and 24, where you're trying to find a mass. Meh, I'm not going to freak out about that. Okay. I think the rest of this is pretty good. Yep, that works, that works, that works. I think those are all good. Let me check the gravity section. Yep, that works. That works. I think we're good. So let me pause the recording. Donk.